Welcome all to Lucas Lanza, the alkali guy. As you all know, I am Lucas Lanza, the alkali guy. Well, now look at the time. Well, I guess it's time to go to our next hot topic for today, the alkali metals. For those of you not familiar with the alkali metals, these metals occupy the first column of the periodic table. Now, you might be saying, Lucas, hydrogen is in the first column. And you would be right, but it's not an alkali metal, so we're not going to cover it. Well, to start out, they all have one valence electron. This lone electron means that the alkali metals usually form a positive ion or cation when reacting with nonmetals. The alkali metals include lithium, sodium, potassium, rubidium, cesium, and francium. As you go down the chart, the alkali metals become increasingly soft, and they're all great conductors of heat and electricity. Also, atomic mass increases as you go down the chart. Now, one primary characteristic of alkali metals is that they're all One primary characteristic of alkali metals is that they are all reactive to water. If they come in contact with water, they create an alkaline solution. And their reactivity to water increases as you go down the chart. Now that we've gotten that all cleared up, let's talk elements. First element up is lithium. Lithium is the lightest metal and the least dense solid element. Because it's off the charts in terms of reactivity, it does not occur freely in nature. Instead, lithium is present in ocean water and can be obtained from things like clay. But if you want to make the dough, lithium can be extracted from lithium chloride and potassium chloride. If you want to find some lithium around your house, let me tell you where to look. Some traces can be found in heat-resistant glass and ceramics and other things of that nature, but the mother lode is right in front of you. Lithium batteries. Lithium is often used in batteries because of its high charge and power-to-weight ratio. Lithium-ion batteries are also common because they're rechargeable. Next is good old sodium. Sodium is not the first, not the second, not the third, not the fourth, not the fifth, but the sixth most abundant element in the Earth's crust. Fresh off the chopping block, sodium has a bright silvery hue, but when exposed to air, it will quickly tarnish and lose that. Much like a boy's dream can fade when his parents tell him that he'll never succeed at becoming the next Bill Nye. Well, look where I am now, Mom and Dad. And we're back. So, sodium exists in many minerals, such as feldspar, sodalite, and rock salt.
Sodium, yes, sodium, exists in lots of minerals such as feldspars, sodalite, and rock salt. Sodium is easily dissolved and has a silvery white hue.
The next element we're going to talk about is potassium. Potassium, in its element nature, is a soft silvery white metal that reacts vigorously to water. Potassium is chemically very similar to sodium, but sodium only wishes it was potassium. Potassium is only the second dense metal. Second most dense? No, I'm not good, I was kidding. Potassium is also the second least dense metal after lithium and can be sliced and diced by a butter knife. And now, the moment you've all been waiting for. Hey, tech support! Oh, you're gonna miss out. You guessed it, bananas. Bananas are a fantastic source of potassium. The potassium found in foods such as bananas helps to rebuild electrolytes in your system, and a lot of other nutritional stuff. Next up to bat is rubidium. Interestingly enough, rubidium was discovered in 1861 by chemists Gustav Kirchhoff and Robert Bunsen. I am lighting the burner. Yes, that guy. Rubidium is super soft, ductile, and like many of the other alkali metals, has that super soft silvery white hue. Rubidium is not the first, not the second, not the third, not the fourth, not the fifth, not the 22nd, but the 23rd most abundant element in the Earth's crust. Right behind sodium and 16 others. Rubidium is often used in the production of fireworks, which we would love to show you, but somebody got busted trying to buy them in the Walmart parking lot. Due to its intense reactions, rubidium can spontaneously cause fires, so it's usually kept in the equivalent of a supermax prison. Up next, cesium. Shoot. Cesium has a silvery gold color, and like all of the other alkali metals, is extremely reactive when coming in contact with water. So reactive, in fact, that it will explode even at the lowest temperatures. Cesium has a low melting point of 83.3 degrees Fahrenheit, and it is the softest of all the elements. Cesium was discovered in 1860, also by the dynamic duo of Gustav Kirchhoff and Robert Bunsen. I am lighting the burner. Yep, that guy again. Cesium is closely associated with rubidium, but is only 3.3% as abundant. Rubidium will not be found lying around on your house, like our tech support. But it's primarily used in the process of oil drilling and is sometimes found in atomic clocks. Finally is francium. Francium, as early as 1870, was suspected to exist. Then multiple people further researched it, but its discovery was credited to a French chemist named Margaret Perry, who named it after her beloved country, France. Francium is extremely rare and extremely unstable, making it very difficult to view in quantities large enough to see. The largest amount ever produced was only 300,000 atoms. Hey, tech support?
Oh, yeah.
Alright. The chemical properties closely aligned to those of cesium, and it's one of the most unstable of all the naturally occurring elements. To review, the alkali metals include lithium, sodium, potassium, rubidium, cesium, and, last but not least, francium. All these metals are extremely reactive to water, and they all have one valence electron. Signing off, Lucas Lanza, the alkali guy.